Let's look at independence and conditional probability. First of all, our experiment is choosing a card from a standard 52 card deck. Event E is that the card is black. Event F is that the card is a spade. I want to know if they're independent. Okay. To be independent, I would need that the probability of their intersection is the product of their probabilities. So this is what I'm going to check. Well, the probability of their intersection, the intersection of a card being black and a card being a spade is a card being a spade. And there's a 1/4 chance of a card being a spade. Probability of E, well, the probability a card is black is 1/2. Probability of F is the probability of a card is a spade, which is 1/4. So now I'm just saying, is 1/4 equal to 1/2 times 1/4? Answer is no. They are not independent. Okay. Now, let's do some examples of conditional probability. In this experiment, we have a bag with 5 black and 4 white balls. 2 are drawn in succession without replacement. First, I want to know the probability that the second is white and given that the first is white. Now, to help me with this, I'm going to need some probabilities. So I'm going to take some time and draw a little tree diagram just to get the computations of the probabilities out of the way. For my first draw, I can be black or white, and then for the second, black or white from there. Now let's fill in the probabilities. For the first draw, I have 9 balls. 5 of them are black, 4 of them are white. If I chose a black ball first, I'm left with 8 balls. 4 of them are black, 4 of them are white. If I chose a white ball first, I'm left with 8 balls. 5 of them are black, 3 of them are white. Okay. This just saves me the trouble of computing the probabilities individually when I'm trying to do my computations. Now, by definition here, we're looking for the probability of the intersection over the probability of the second one. The intersection of second being white and first being white is that they're both white. Okay, so I'm going to get white, white. So, the probability they're both white means I'm following this path down here. So it's 4/9 times 3/8. The probability the first is white is that I followed to here, just 4/9. Okay, this gives me a probability of 3/8. Notice that's the same as if I just started at the first being white and followed the path to the second being white. So let's employ that method down here. I want the probability that the second is white given that the first is black. So I should be able to start at the first being black and say, what's the probability of ending here? 4/8. Okay. Now, we're going to do one big example using blood types. Up here, I have the possible blood types and the percentage of the population with each of them. It's going to be helpful for what follows to know the total number that are positive or negative. So I added those up. Okay. As well as the total number that's A, B, AB, and O. Okay, so I get 42, 10, 4, 44. Okay, now, I want the probability that they are A, given that they are negative. I'm not actually going to use probabilities here because I don't have to. I'm going to use numbers. So how many of these out of the theoretical 100 we have are A, given that they are minus? So on the bottom, I'm counting the number of minus, and on the top, I'm counting the intersection of these two, the number of A negative. So I get 6.3 over 15. Okay, this gives me 0.42 probability that they are A, given they're negative. Okay. Here I want to know what's the probability of them being plus if they are B. So I'm doing number of B on bottom, number of the intersection, which is B plus on top. So 8.5 divided by 10 is 0.85 probability. Okay. Here I'm doing on bottom the probability or the number that are positive, and on top the number that are AB positive, which is the intersection. So 3.4 divided by 85, okay, gives me 0.4. Okay. Now, down here, I'm doing the number that are O divided by on top the number of the intersection, which is O negative. I knew something was wrong. I was missing a 0 on that one. So here we have O negative is 6.6 divided by total O is 44, and I end up with 0.15. Okay. So again, for conditional probability, it's always the probability of the intersection on top and the probability of the given information or the second term on bottom.